Let's welcome Mr. Sudarshan. Over to you, sir.
Yeah, thank you, uh, Devanshu. Am I audible?
Yes, sir, yes, sir. You are audible,
Yes.
sir.
Okay. So, welcome all. Good evening from my side. Uh, Today we are covering the additive manufacturing step by step, 3D printing processes and their workflows, and the applications in various industries. So we just start with this, and in this next 1 hour, we are going to cover these things for the applications for aerospace, automotive, and different type of industries. So before we going to the details, I just explain the agenda for this webinar. So first we start with the introduction about the additive manufacturing and their history parts. And the second, we see the additive manufacturing workflow. So universal workflow for the additive manufacturing, we are discussing for that. Third one, we have one our internal case studies. We do the projects, so that one of the case study I'm sharing with you all. Then after that, we just see the key 3D printing technologies. I include the SLA technologies and FDM, SLS, and DMLS technologies. So, how these technologies are work, what are the applications for these technologies that we will see in this webinar. Then next step, we doing the software demo for Fusion 360 and Preform and Eiger. So Fusion 360 is basically for the CAD modeling design the parts, and the preform and Eiger we are used for the slicing or the 3D printing the part. So that we will see. Then after that, these four technologies we compare as per the application where we use these technologies according to the specific applications. After that, we see the additive manufacturing future trends, means the market size of the additive manufacturing. And lastly, we see the careers and opportunities whoever join the like students for the in future they have any careers and opportunities in additive manufacturing. So just we start. Okay, so first of all, what is additive manufacturing and what is the subtractive manufacturing? So in this video, you see the left side, the material can added layer by layer with the help of a digital file. So in additive manufacturing, we are creating from the base. Wherever the material is needed, we just add layer by layer. Exactly opposite, you see in subtractive machining, you see there the billet of the block like in metal, we remove the material. So that is a subtractive process. So these are the two process exactly opposite to each other. Here in I just okay. So now this is the flow of the subtractive machining. We take a solid block and with the help of drilling and machining, we can remove the material as per the model. Apart from that, in additive manufacturing, we just create the material, means the layer by layer, we can print the part. So the complexity part we can easily print in additive manufacturing, where the part selection criteria for additive manufacturing is like that the part will be complex in nature. So that kind of thing. I hope you understand the difference between the subtractive machining and the additive manufacturing. Okay, we'll go to the next slide. So the history part, if you see 1983, SLA was invented by Chuck Hull, which is the first person who patented this technology in 1983. After that, 1989, FDM technology is patented by Scott Crumb file, the patent for fuse deposition modeling. And after 1989, so the reprap era is coming. So from 2005 to 2009, most of the patents are expired, and more of the like more people can use this technology and create the new technology in that. So in that era, so some students also can do the reworking on this 3D printing technology and develop the new 3D printing. technologies. After that, in 2020 plus, the industry 4.0, then it shifted to the metal 3D printing, which is DMLS technology. Also, the continuous fiber we can use for the reinforcement for to increase the strength of plastic polymer, and digital warehousing for the production of the industry. So this is the history part of the 3D printing. So we'll go to the next slide. If anyone having the questions, please type in the chat box. We'll answer after this. So in industry 4.0, we see the digital warehousing means here normally the people can do the inventory for the specific spare part. So here 3D printing create a major role to on-demand supply of the parts where you needed, when you needed, you can easily print it and use it. So it decrease the inventory, okay, and the warehouse not required the warehouse to the store the maximum inventory in the plant. So we can print globally, means you can send the file globally and we can print locally. That is the decentralized, which is a very time saving, as you see. This is the digital warehousing, and we'll go to the next, the universal AM workflow. Okay, so if you take a printer of 50,000 to the 12 CR, the workflow will same for the all the technologies, minor here and there, but the universal workflow is the same for the all AM technologies. So first we start with the CAD model. If you see in the image, we first required a digital 3D CAD file. In that, we learn about the part screening for specifically additive manufacturing. We cannot print any part in 3D printing. So there is some criteria to define this part is fit for additive manufacturing. Some complexity is there. So that type of part we can take for the additive manufacturing. Then after that, the part geometry, according to the part geometry and application, we select the technology for that, which some technologies required support structures, some technologies not required support structures. According to that, the application, we just select the 3D printing technology. After that, creating the 3D modeling with DFM. The DFM is one of the concept in additive manufacturing where we can design the part for additive manufacturing, like self-supporting structures, like lightweighting. We are using a topology optimization to reduce the weight, part consolidation, some assemblies we can create into the single part. So that will use to take a benefit of additive manufacturing. So like that, we just design the parts and according to the application. So here for design CAD softwares, we are using multiple softwares like Fusion 360, SolidWorks, CATIA, NX. So these are the softwares we can use for the creating 3D models. Then after this first step, we go for the model conversion into the print file format, which is .stl file format, which is mesh file. So we can create the mesh file in .stl file as well as .3mf file. So both the formats are okay to take for the next step. So here we be careful about the triangulation and resolution of the file. If you create a maximum size of triangle, so the accuracy will vary according to that. So we focus on the accuracy. So we have to create the STL file with high resolution file, then you will get the better dimensional accuracy. So that is the thing, one thing we important to consider that time. So after conversion of to the CAD file to STL file, we'll take that file to the slicing softwares. So in this image, you see some of the support structures are there, and this is the part. So in this process, we do the feasibility of the part. In feasibility, we consider the orientation and the support structures and the functional area where we are the important surface. So where we try to avoid the support structures because some surface is required, the high surface finish. So that time, according to that, we just orient the part, then support structures creation in that, and the layer height means we have to slice the part by the layer height, because additive manufacturing, we create the part layer by layer. So that's why we have to give the layer thickness. So certain layer thickness is vary from 25 microns to 80 micron. Some technologies use 100 micron as well. Some technologies 250 micron is also there in FDM. So in DMLS technology, we vary from 25 micron to 80 micron. So we can print the part. At this time, we calculate the printing time as well as the cost for the that specific part. So we'll do the parameters, which materials we are using, and apart on that basis, material cost and the printing cost, will calculate the total cost for this part. Then after STL repairing and support generating, just we go to the next step. This file is transferred to the 3D printer. So here I'm showing the SLA Form 4 machine. So after file transferring, machine preparation is there, some material loading, some cleaning process for the build platform, and that activities we doing, and we start the printing. After the printing, we can unload the part and the process optimization. Then next step after printing, we go to the post processing. In post processing, in SLA specifically, we required just like a, removal of supports. If you see here, some support structures are there. So this is not a part of geometry. So this is we just a temporary given that. So that's why we have to remove that. So that's why the next step, we just remove the support structures, and that gripper we just put it into the just like a heat treatment process for this. So it's also called as curing, to harden the part, because in SLA we'll get the soft part. So to the harden and for the final application, we have to do the thermal treatment on that. So that's why we are just using the curing unit. In metal, we are doing the heat treatment. Some machining is also there. So these are the post processing steps we are uh, taking into the consideration at the workflow. And after post processing and the final machining, the important part is that the quality. So quality and inspection is must, as per the CAD geometry we create the part or not, that we have to check. So some inspection like visual and dimensionals also. Sometimes we 3D scan the part according if the geometry is not even. So the complex geometry is there. Then we can use the scanner as well to compare the part from the digital file to actual file. So that is the thing. So this is overall workflow of 3D printing. Just we start from a design to how we create the up to quality. So that is the thing. I hope you understand. If you have any question, please ask in chat box. Then we move to the next slide. This is the three technologies right now we have in uh, our institute. So we have a
Sorry to
solid
interrupt.
base. Yeah.
Can we
Yes.
take one question here?
Yes, please.
So Deep Shah has a question. Is Blender used for 3D modeling for printing?
Yes, yes, sure. The Blender is also we use. The output should be a .stl file. As you see in Blender, we can get that format. Definitely, we can use Blender as a for this. So the our output required from the software is .stl file. So we can easily print that part in our machines. Yes. Okay, Divanshu. I hope this.
I hope Deep Shah, you got your question. Can you respond in the chat box if this is okay? Yeah, yeah. So we got a message from Deep
Okay.
Shah.
Yes.
He said it's okay. Okay, sir.
Yeah. Thank you.
Okay.
So
Now we can move ahead, sir. Thank you.
yes, sure. Thank you. So in our institute, we have these three machines for the 3D printing course. So first we have a solid base 3D printing, which is use a filament, just like a FDM and FFF. So here we can use filament, polymer filament with the heated nozzle. We can print the part layer by layer. Second technology is SLA. It's also called as DLP. So here we can use material as a liquid photopolymer resin. So photopolymer resin is in nature, is in contact with the UV light, it will harden. So that technology we have. And the third one is the SLS. We have a Fuse 1 plus 30-watt machine to get a hands-on on this technology. So one by one, these technologies we see in depth in next slide. So we'll move forward the next slide. So this is the first technology, which is MSLA. So in MSLA, we is also called as mask stereolithography. Here, we can use the powerful LED light source to selectively cure the photopolymer resin. If you see in the video, so this is the liquid material we are using, and this is the build plate, and this is layer by layer. We can print the part with the help of curable resin. So it will get the final 3D part. The advantages of this technology will get the 50 micron accuracy in XY resolution. So we'll get the high accuracy part. So here in image you see this is the build plate, okay, and this is the tank here where we can add the resin. Sorry. So this is our recoater to move the resin layer by layer, and this build plate goes from bottom to top. So this is the process for that. And this technology use for jewelry industries most of the things, and dental applications. Some of the accuracy parts we can use this technology. In this technology we just do one case study that I just present in next slide. So we'll go for that case study. So this is our internal case study. Our trainee do this part design and the 3D printing. So this is compact vacuum gripper, which is used to lift the cubes, as you see in the this image left side. So earlier there was a single vacuum gripper which is lift only one cube at a time. So we redesign this and you see here at a time we can lift up the four cube at a time. It will reduce the cycle time up to 75%, and the productivity also boost. Also the load capacity also increase for this. So that is the first we work on the problem statement, where the gripper was limited to handling one object at a time. So we think about that what will be the solution to increase the cycle time. So we create a four. Also, some large object lifting also. This gripper is not that much strength to carry the bigger size block. So that's why we optimize the design for the 3D printing, and we'll print in fast model resin, which is having the 62 MPa tensile strength and 106 MPa flexural strength, which is suitable for this application specifically. So before we selecting the material, we just check their mechanical properties, it will sustain or not. So that is the guideline for the 3D printing when you choose the material and the technology. After analysis, we'll do get these results. We can reduce the 75% cycle time. One short video, I just explain how step by step we go for this case. So just you see in this image, we have this on robot head, which is having a single vacuum gripper. If we want to get it for, we have to purchase another head for this. So our student identify the problem and solve this to create this type of CAD model, and we can print this. So just video I'm playing, I'm explaining in that video. So as I show earlier, the universal workflow. So first we do the CAD modeling in Fusion 360 to create all these things, and then second step we just prepare the machine, that material loading and the build plate. We'll just check it is properly clean. Then after we take that file into STL format to the preform software, and we orient like that. The internal area will not get supported. So then next step to the preparing the machine. Uh, Here some cleaning process is there for the build plate. We check any dust particle will not be there in the on the build platform. And after that, we just OK to the machine and we start the printing. So if you see, the layer by layer printing will happen here. And after printing, we just remove the part from the machine and we'll do the post processing. As I say, support removal is the first step. So in SLA, we do the washing first. So we can remove the resin, which is trapped inside or in supports also. So that we will remove. And after that, we just in IPA liquid, we just clean this gripper part, thoroughly clean the first the resin, and after cleaning we just do the support removal. In that, this is the secondary cleaning, and we do the support structure removal here. So with the help of plier and chisel, we can easily remove the supports. So this is the final model. So, but this is uncured. So this we will not use directly. So we can use the next step to cure. So this is a curing unit. So we have some cycles up to 65 degree. We kept the part 15 minutes in under the UV light, and then we can take for the functional test. So this is the initially, if you see, the single block will pick and place in this box. So after optimizing this at a time, we can print the four block, lift the four block and place in this box. So instead of that, the small, we can lift the bigger block as well, up to 1 to 1.5 kg load it will it can take. So this is the final case, and we just drop the cube in box. So as you see, at a time we lifting the four blocks, so that's why the cycle time will reduce instead of that. Okay. Then just I put a video how to design this gripper. We started from design, so some sweep command we are using and multiple uh, mirror commands are there. A pattern, we pattern that, and this is the design procedure. Also, I show in software as well the same thing. Okay. The next technology is CFF, continuous fiber fabrication. This is one type of FDM technology where we can use the multiple materials. Like we are using two materials. One is polymer filament, and second is reinforced material like carbon fiber, Kevlar, and high strength, high temperature fibers here. So in this technology, if you see, the printing happens layer by layer. And in this image, you see the outer side, we are using the polymer filament, and inside you can use the high strength material, which is carbon fiber, which is having a strength up to aluminum material. So if we print a part onyx with the carbon fiber, it will give us the strength nearby aluminum material. So, and this also having uh, application in tooling fixtures we can create from this, and multiple drone applications also this technology is used. So this technology we have in house. Then third technology is SLS, where we are using a powder as a material. In CFF we are using a filament material. In Formlab Fuse 1 plus 30 watt, we are using a powder as a material. As you see you in video, the 30-watt laser we can use to sinter the powder. So multiple materials like nylon 12, that these materials are we are using. So this is the finished component image. If you see this side, so in this we have a three unit. So first is a 3D printer. Then second is a shipped unit where we can remove the parts and recover the used powder for the recycle. Again, we can use this powder to the printer, and we just clean the part here because this technology is not required the support structures. The powder is act like a support structures. So previous technologies, SLA and CFF, they are required support structures. But this SLS technology having one benefit, we are not required any support structures. So any complex geometry you can print without support here. So after cleaning the part, we can take to the next procedure, which is short blasting, where we can use a different type of media to improve the surface finish in short blasting machine. So this process having these three units. So these three unit complete this technology. So as you see here, the recoater recoats the powder layer by layer, and laser will sinter the according to the CAD geometry to this CAD file. Then next technology is DMLS, okay, which is a very mainly used in functional parts in aerospace, defense, in medical. So this is a metal additive manufacturing technology which is powder based. Definitely, we are using like in SLS we are using the polymer uh, powder. In DMLS technology, we are using the metal powder. So in metal, we have multiple materials like titanium, Inconel, maragin steel for the tooling industries, SS316L. So these are the multiple grades and upcoming new developments also happening in this technology to develop the material for the specific application, like a space industry, jewelry industries also. This technology is used. Maybe gold powder is also precious materials also available in this technology. So from this technology, we will get the functional part as well as the dense part, which the density is around 99.9%. So that dense part we get from this technology. So it's highly used in industry for the functional parts. So the same structure like SLS, we have a laser unit of the top, and we have one compartment where we put the fresh powder. This roller move from right to left side. So it will spread the powder on this platform. So this is a printing area which is having a size of 250 by 250 by 300, or maybe 400 by 400 by 400. According to the machine configuration, you can take the build size. So that size part we can print here. So according to the CAD geometry, the laser will melt the powder precisely there, and the excess powder we can collect here. So this is called as collector, and this is a dispenser where we can put the fresh powder. And after layer by layer printing, so bed goes down layer by layer. What will be the, you just decide the layer thickness according to that program. Layer by layer, this bed goes down, and after finishing, we just remove the parts and do the post processing as I show in workflow. Then I just show the demonstration first, the 3D CAD modeling for Fusion 360. I just stop sharing and again I share my screen. Just 1 minute. Okay. Is my screen visible? Okay, thank you. So this is the model which I'm talking about. So this is the vacuum gripper. If you take the section here, so we just create the hollow portion inside to get the vacuum and grip the parts. So this is the first section, and this is the second. You see here is the four hollow sections we are taking. In this, we just creating most of the commands like sweep, mirror, and the thread command is there. So, and we can check also layer by layer in next software. So this is the one of the design for our internal case study. Now, second, I want to show the lattice structures in Fusion 360. If you are aware of the CAD softwares, definitely you know about how to create the solid geometry and this surface models here. So I'm just showing one feature which is lattice structures. So we are using lattice structures for lightweighting the part to not removing the like a strength, means the same strength with lightweight we are creating the part. So this is one of the option. So just for example, I'm taking this bracket and I want this area for the lightweighting. So I just select that area. So directly you get the lattice structures. You can create the solidity also. Just you want less solid, then you can adjust the thickness also for this lattice, and it will create. So this is the by default library for the this volumetric lattice. You can directly go and multiple options are there. You can select for the lattice. So here this is the second structure. But what if you want to research for the new lattice structures? So you can create the structures as well. What you want, just create the CAD model for that, and you just select the lattice command. And here there is one option. First, I select the body. So it will take by default library material or the type of the lattice. So here is one option, custom. In custom, we just select the this geometry. It automatically replicate on this. So here you see, you just reduce the solidity, then you will get the structure. So see, so one cell we need to create here. So that cell will multiply in this area. So we'll get the lattice structures. So this type of applications, and this will not possible with the conventional machining process that we will only do in 3D printing. So it will easy to create, and after that we also simulate uh, this lattice strength also. Then third one is generative design in additive manufacturing. I just say like this bracket. I just already do the simulation. So this is one of the bracket, GE bracket. So here, this is the well-known case study. Also in so here we can reduce the weight according to the this part we can manufacture by traditionally. But if you go to the additive manufacturing, same part we cannot print because there is no any point to print this same part with the 3D printing. So for next step, we are doing the weight reduction. So that's why we just optimize the part according to the boundary conditions. We are giving the load and the constraint. So just redesign the part. We can that is possible in generative design, and we can easily print in 3D printing. Loading. So give us time to loading. Uh, in time, we just go for the next software, which is the preform. So after in Fusion 360, okay, it's loading. So you see, this is the modified iterations. They give us the solutions, multiple iterations it shows. In that we have select the which is the right one. So according to the weight and your application, you just select the multiple iterations here. So here we get the details, the material we are giving for the simulation, titanium 6Al4V, and the volume for that. According to the criteria, you select the one of the options and you can print easily. So this is one thing for the design software. Second, this uh, compact vacuum gripper, we just export as a STL. As I say, from CAD model to we required STL file format. So here is the STL format. You directly export this and we'll get the STL file from our next software, which is Preform. I just show that software. So this is a GUI for Preform, which is for Form 4 machine. We are select the machine here, as well as we just select the material and the layer thickness. If you want to change the material, there is a library for the material. So right now we are selecting the fast model, and here we select the layer thickness for that. So specifically, I want to print in 0.2. Just click it on and OK. Then next, that STL file I'm just taking here. So selecting. Okay, so this is the orientation for this. If I generate the supports, if in this orientation I try to print, just we create the supports first. So, so these are the support structures. But if you take a slice view, you see inside the channel we get the supports, right, which is not removable, because we don't have access to remove the supports from this side also and from this side also. So we have to take care about the support where we are generating. It should be removable or accessible after the printing. So that's why orientation come into the picture. So multiple orientation we have to try and to avoid the supports. So we design this part such a way, if we can kept vertically, it will not get supported inside. So I just create the support structures once again. So see, the outer side only supports, and we go to the slice area here. So if you see, the internal channel does not get supported because we create a structure like that, which is self-supporting. Like if you see here, so this is the self-supporting angle, which is more than 45 degree. So we can easily print this part in within a, you see, 50 minutes, we'll get this part. So for this 36.17 ml material is used. For specific support, we are using 4.26 ml. And for model, we are using 25.87 ml material. So you will get all the information here for the summary, and this part will ready in 50 minutes only. So directly after this step, we can directly send to the machine for the printing. So this is one of the software for the slicing, specifically for SLA and SLS. So both the machines we have used this software. Then third software for the FFF technology, I'm just showing. So this is a cloud-based software, Iger, which is used for the Mark II machine. So we'll take one example. This is a spinner part. Okay. So here we get the part details, the size of the part, how much the part size, and here we are using the which materials we have, and the machine. Okay. So multiple machines from the Mark IV side. Metal X is also there. So we have desktop series Mark II machine. And here we use the polymer material, and second is reinforcement. So reinforce, we can use the carbon fiber here. So automatically, if we are using nothing, only the polymer, the setting will give us the access to increase the layer height. So you increase the layer height, the printing time will change. So according to the layer height, printing time will be less. And if we are selecting the carbon fiber for reinforcement, the layer thickness is locked for that specific standard. So we can print only 0.125 height. So here we can calculate the details. So is adding the carbon fiber in this geometry. So outer side we are using material onyx, and inside that we are using the carbon fiber. So just we see in the X-ray view, I just show. So this in X-ray view, we'll get the identify easily where is the exactly carbon fiber we are giving. So in 3D view, we just see here. So layer by layer, if you slice the part, you get the notification. The blue part, you see the lines. These are the fibers. White for the part geometry. So you can also add in between if you want to add some more strength or more, then you can easily create and add the fiber in that. It will get more strength. So in 3 area, we just put the fiber here. So if you don't want, just select it and delete it. We'll get reslicing. And if you see, the bottom side and top side only I'm using the fiber to get a strength of the material. In this software also we are doing the infill patterns. Multiple infill patterns are there, like triangular, hexagon, rectangular. So in that, if you see, now we are using triangular. I just go to the X-ray view. If you see the internal hatching lines here, so these are in the form of triangle. So if I select the hexagon, it will come in the hexagon to infill this area. So this is all about the Eiger software, where we can explore for the CFF technology. In that, we are adding the carbon fiber with Onyx. Okay. So I show the next slide, few of the projects done by our trainees with the help of SLS, FDM, and SLA technologies. So this side, you see, this is the helmet, which is redesigned by and using the lattice structure for the lightweight. It is print in nylon 12. The second, this is a prototype for Soviet N-1 rocket. So this is a miniature for that, and stage by stage, the separation it will happen. So they slice the part, cut into the different uh, portions. This part is the world skill welding competition part, where this part is demonstrate how we weld the part step by step. So that demonstration, we print this part for the internal education purpose. Uh, then next, we are having a close impeller, open impeller. So these type of parts we can print easily, like a proto or some fitment parts also. So this is the air intake manifold from automotive industry. So these are the projects. Then next, we just see the comparison of these four technologies. I'm considering only these four technologies. There are multiple technologies also available in additive, but today's webinar, I'm taking these four technologies. So first of all, the material type, as we see uh, in CFF technology, we are using the filament as a material. So fiber reinforcement is used for that. In SLA, we are using photopolymer resin, which is cured by UV light. So in the liquid form, and then SLS, we are using a powder like nylon TPU powders will be there. And DMLS, we have metal powder for the titanium medical grade also and engineering grade also. And the accuracy, when we go to the accuracy, so in SLA, we'll get the more accuracy. Other technologies require the post processing for that. But if your application is like only to show the parts or no heavy application, that time only you go to the SLA technology, because this technology parts are brittle in nature. Other technologies, if you see, some strength of the part will be there. According to the surface finish, you go to the if any lightweight application part, you go to the SLA, which is very smooth finish. The functional part in heavy application part, you go to the DMLS, which is high strength part we can create through metal. Initially, the roughness of the metal 3D printed parts is around 8 to 11 RA. Will get the surface finish. According to the part geometry, it will vary. Maybe sometimes you get more rough part due to the downskin or the orientation. But fairly, we say 18 to 12 something RA will get. After post processing, you will get the machine finish as well. So according to the applications, you just select the technology in that. The support structures, if you see here, in three technologies like CFF, SLA, and DMLS required the support structures to support the part, and also the heat dissipation in metal specifically. For a heat dissipation purpose also, we are giving the support structures. In SLS, there is one benefit I already told, like no support structures is required because the powder is self at like support. So that's why in SLS we not require the support structures and we can print the part without support. The cost wise, if you see the technologies, definitely metal is high. because of the powder cost also and the inert gas at atmosphere we are using. So DMLS we are using argon and nitrogen inert atmosphere environment to print the parts. So that's why the costing part for metal is high. And the other technologies in polymer, just like medium and high according to the material price and the printing time. For primary use cases, for your application, like if you want the functional prototypes tooling, so you can go to the CFF like fixtures or aluminum. You want to replace the aluminum parts into the polymer ones, so you can go with the onyx with the carbon fiber. It's nearly equal properties you will get. In SLS, some functional prototypes, definitely you go for the SLS. If you have only visual prototype or dental models or intricate shapes, so you can go to the SLA technology. And definitely DMLS having the major role in aerospace, medical, and implants, so and industrial applications like automotive, jewelry also use that. So these are the total comparison points I am consider here. Next slide, just the application. I am mentioning the industries. So definitely aerospace, defense, tooling industries require the DMLS technology for the inserts. In tooling industries, we are from additive manufacturing, we are provided multiple cooling channels for the increasing the efficiency of the mold and the increase the productivity. So reduce the cycle time also with the help of cooling channels. In jewelry, SLA 3D printing is used for to get the uh, we have a castable resin material where we can create the jewelry models in that printer, and we can easily cast in a gold. Next is automotive. Automotive industry is very vast industry to get the multiple parts in aluminum material. So DMLS technology definitely more into that. Also SLS technology for the fitment parts we can use. In medical and healthcare, we are using titanium, cobalt, chrome materials are there where we can use for the medical customized implants like cranial plate and accidental cases. So we print the medical implants easily in titanium grade material. Again, other industries like architectural and construction also using the 3D printing to build the buildings also. Latestly, I saw the Godrej is using the 3D printing for the cement. They can build the villa in Pune. So that also the one of the application for additive manufacturing. Next, future trend as one of the report I get right now in 2025, 6.68 billion global market is there in 2025, and continuously growing with the ratio of 13.72% from 25 to 2034 will get the market value around 21.23 billion here. So this is the market study which we are taking from the internet, one of the agency. So job opportunities, if you are looking to enter in this field, specifically for the technical roles or design roles. So these are the few I mentioned few positions where you can see. First is AM technician. If these are the technical roles, so where a machine setup is there, calibration process is there, some maintenance is happen, so you can do the maintenance for the 3D printer. Then second position is machine operator, who is loading the material, unloading the parts, material there, monitoring the process where we can do that. Again, the quality is the main area where we can inspect the part as per the standards, because in aerospace you are supplying to the part, we require a specific AS9100 certification. According to that, we with the guideline we have to supply the part to them. So their quality is the main role to check the part quality. In design field, you are looking for There is the AIM application engineer position where the part orientation and the support generation part will be there. In DFM engineer, you see in generative design, we create the optimized model for the 3D printing. That type of job roles is there. In R&D also, we do the same thing. For the new product development, we can do the additive manufacturing. And in process engineering, we can use that. So these are the design roles for the jobs. For this field, we required the job required skill for the additive manufacturing. You have to be CAD software proficiency, slicing software, which I show, and multiple softwares also. Cura is also there, Magix is also there, NetFab. So multiple softwares are there. You have to be expert in that software. You fair idea about get the fair idea about that software and the machine operations troubleshootings. You also know about the materials, material properties like mechanical properties and chemical properties for that, and also the quality control and safety protocols. Apart from that, some communication and collaboration. These soft skills also required for this. So this is about the all skill you required to enter in this field, additive manufacturing. Okay, yes. Thank you.
Thank you, Sudarshan sir.
Yeah.
Thank you. It's a wonderful session. I too was involved too much into it. So guys, if you have any questions, now is the time. You can raise your hand and can also ask question in the chat box. So yeah, let's bring on the queries and doubts if you guys have. Anybody? So yeah, we have a question from Narpat Suthar. Is there any free software model available in the market for this designing purposes?
Free software.
Yeah,
So
or
there
open
are
source software.
yeah, open source softwares. There is earlier one person is asked about the Blender. Blender is also freeware. Also FreeCAD is the one of the software you can use. Also Solid Edge you can try, which is the student version you can use. Some limitations are there for that, definitely. If you are going to the commercial license, they'll some additional model you get. But yeah, these are the 3, 4 softwares like FreeCAD. You can use open source. You can any way install at a time. No issue.
Okay, uh is that did you get your answer, Narpat? Can we get a reaction or can we get a message from you? Yeah. So there is another question, sir. How to learn about different material strength and material science?
Yes, you have to study the multiple materials. You get the material data sheet for each and every material. And also you do the higher education for metallurgy, that kind of thing. So you can that in that course you will get all the related to the material. And also you start the in additive manufacturing field, you definitely know about all the additive manufacturing materials, how it works, and what are the properties of that material. So in our course also we include the material as a one topic where we can teach the student about how to read the material data sheet and identify the materials as per the application. So that will be there. You can go through the material data sheet. You will get the knowledge about the material specific mechanical properties and chemical properties for that.
Okay, so from one question from Priyank, how to start the business about this field for additive manufacturing and where to start?
Yeah, so first you have to select the market need. Means you research on the market need in your area specific, which parts are manufactured, like polymer is there or metal is there. Because if you see the polymer printers are very less in cost, it start from 25,000 as well. But if you go to the metal, uh, that will costly about start with the 8 CR. So, according to the budget, so initially started, we start with the polymer 3D printing. Like in SLA also, you can do some jewelries. Jewelry, you have to connect with the jewelry contacts. Then you can easily start with the SLA, and you can use the castable resin material there to support them. and that also the case study for the highest revenue generation. Also the medical grade materials also available in market. So you can, as my suggestion, you start with the polymer technologies. First you have to study for the market for your business. So that's after that you can start with polymer first, and then step by step you can increase the machines and go for the metal as well.
Okay, so there are some questions regarding the start time of the courses. So, Pratmesh, we have this course for around 3 months. So, every 3 months we start enrolling for the courses. And for more information, I have put all the relevant links in the chat box. You can go on our official website, that is tataias.org, and through that you can also go to the IAS Mumbai, because we have two campuses. One is in Ahmedabad and another is in Mumbai. So you can select your location. According to that, you can choose the timing of the courses and what kind of courses you want to take. Uh, there is another question. Will you provide placement? Yes, sir. Arjun, we provide placement supports, and it's totally dependent on your interview, how it goes and how well you learn in Tata IAS. So based on that, you will land a good job also. There is a question, sir. Will you be teaching about ZBrush?
Right now, no. We have Fusion 360, Preform, and Iger. These are the softwares we are teaching. Yes.
Okay. And how much the cost of machine of SLS?
SLS, for if you definitely go for the Form Lab, then it will be around above 1 CR is the
Okay.
cost. Yeah.
So that's why Tata IS bring all of the machine under one roof with you for you guys. So I would like to request you to check our website. I have given the relevant links to the website. Also, I have given a feedback form in the chat box. So if you can give your precious 2 minute time to fill it so that we can provide you a better experience next time to improve these kinds of free sessions. So, so there are many questions. People are overwhelming with your explanations, I think. So, acrolithericin used in SLA. It's a question, sir, from Rajput Hemraj Ashobhai.
What is acrylic steering resin? Okay,
Yeah.
this I need to check that material, but maybe it will be used because it is in the photopolymer form. We can use that material in SLA. Yes.
So all the questions regarding placement assistant and hostel. So I'm just taking, give me just 1 minute. I know we are already past the time. So just give me 1 minute. I'm sharing my screen so that you can land our website and get all the relevant information from there. You can download our brochure from there. So allow me some time so that I can share my screen. Is it visible now?
Yes. Yes.
Okay. So this is our official website, uh, tataias.org, and there are two campuses. This is IIS Ahmedabad and this is IIS Mumbai. So if you are going for location IIS Ahmedabad, you just click on this logo and we will finally land up here. And here you will get all the information you need about our courses. Mostly Tata IAS and IISM Ahmedabad do courses in these broad domains, that is advanced manufacturing, electric vehicles, electronics, and hospitality. So if you want more questions, more if you answers of your questions, so please download our brochure or explore our courses. And if you think these courses are for you, just register. And to talk to our one of our personal, so you can contact us on this number or can send your query on these admission based mail. Uh, and same for the IS Mumbai. we have added retail sales, a new course in IIS Mumbai. So you can explore all such these courses here, and here is the admission process. So first you have to scan for registration. You will get a Google form. You have to fill the relevant information, and based on that, if you get selected, you have to give a test, and after clearing the test, you will get a call from our side, and you have to pay a confirmation fees to fix your seat. So pretty much if you go through our website, you will get all of the questions, all of the answers you need. So I think it's a great webinar, and thank you, sir, for preparing this session for us and
Thank
letting
you. Thank you,
us.
sir.
Uh, okay. So
Yes.
if there any other question, please do put on our the on the mail ID or the on the link box. So thank you guys for joining on this Saturday night or evening. Thank you.